Hey there, welcome back to this weird programming channel. As usual, I have not yet delved into some simpler vision for my RL algos, but I think it's now important for me to actually explain what I'm trying to do. I'm sure some of you might be familiar with reinforcement learning algorithms, and what I've shown was certainly not something you've seen before. The goal of this video is to give you some hints and pointers to let you experiment just as I have been doing. We need new algos and approaches, and with programming we have an advantage because we can empirically verify if our programs work or not. So what is machine learning really? Simply put, machine learning isn't magic. What most people use is called the Monte Carlo method, or methods. I've done something similar but not quite the same. There is also no optimizer and no derivatives and no modifications, no neural networks. First I'm gonna lay down the rules I've set for myself so that it becomes a bit more clear what I'm trying to accomplish. Here's the rules. No neural networks, no helper points, no helper rewards, assume possibly infinite states, basically a large problem space. If there are rewards in the way, the algo shouldn't get stuck on them. No redo or rewind in the algo. Somewhat general. It can't be too specific, for example, it only working in a tiled game environment. The rules I set out for myself exist for only one main reason: to reduce computation and learning time. Machine learning isn't just about neural networks or commonly known algos for reinforcement learning. Generally speaking, the term machine learning is a bit of a misnomer, and it doesn't have to involve derivatives. It usually does for efficiency reasons, but you can train a perceptron without using derivatives. All you have to do is compare your desired output with the current output, and if the desired output is higher than the current output, subtract a fixed amount like 0.01 from your weight and redo this process, either adding or subtracting to the weight, and you'll get it to a proper result in the end. This is quite inefficient, so derivatives get introduced along with a loss function that you can try to minimize. Using the fixed addition subtraction would also be extremely computationally expensive if you were to re-evaluate the network for each and every single weight. But the general idea still stands. You have a number and you modify that number to best fit whatever output you wish to get. That's it. How you do this and how to do this effectively is where all the scary math gets involved. But it's mostly just derivatives, really. And derivatives are just indicators of the slope of a function. So in case of a loss function, you try to descend to the lowest point, minimizing the loss effectively. There are many better videos if you want to go in depth, but I'm not going to get into that. All I'm going to tell you is that you need to look into auto-differentiation or auto-derivation if you want to build your own large neural network. Without using existing libraries, that's what they secretly are, you know. If you want to do that without using PyTorch or understand how that works, then auto-differentiation or auto-derivation, that's what you want to research, which is what I have done and developed for myself to understand it better. I might illustrate it at some point on this channel, but it's in Perl, so no promises. What I'm getting at is that neural networks in the size they are being made are simply just too big and clunky. Just think of all the GPUs and data centers needed to create something like that. Unreal. I get that it's sort of required if you want to have billions of weights in there, but at this rate you'd need a data center the size of an entire country to advance this approach to machine learning further. and there is no telling if it actually would be able to count the number of R's in strawberry. Anyways, I've been rambling again. I'll leave you with that. Make sure to check out my Patreon if you didn't yet. If you haven't, I'll be doing programming related stuff on a regular basis. I'll try to keep you informed. I used to stream programming stuff, but I don't think I will be doing that. Let me know in the comments if you would like that. And once again, if you like the video. If you could, then subscribe if you want. Mainly if you just want to follow me, don't just click the button, but it doesn't matter. Thanks for watching, and I'll see you in the next one.